Hello and welcome to a short 6-win Turbo IPsec video on secure Site-To-Site VPN. 6-win Turbo IPsec high-performance software runs on commercial off-the-shelf servers and provides a 50 to 80% savings in CapEx when compared to hardware IPsec VPN appliances. It provides scalable performance on demand and is quite flexible with the ability to run the same software on bare metal or as a virtual machine. Site-to-Site IPsec virtual private networks provide secure, cost-effective communication between trusted sites. The secure gateways forming this VPN must meet requirements for performance, security and resiliency, management and monitoring, and virtualization. Next, we'll show how 6-win Turbo IPsec meets each of these requirements. The first requirement comprises scaling performance beyond 10, 40, and 100 gigabits per second with software on COTS servers. 6-win Turbo IPsec leverages multi-core architectures to achieve 12.5 gigabits per second per core of raw IPsec processing capacity. When we add virtual routers, IP and IP encapsulation, and filters, 6-win Turbo IPsec still provides 7 gigabits per second of IPsec processing capacity per core. In both cases, performance scales linearly with the number of cores. Before moving to the demos, the test configuration is briefly described. The demo test configuration comprises an Intel x86 commercial off-the-shelf server with 14 cores, 4 10 gigabit Ethernet ports, and a single 100 gigabit Ethernet port. The 100 gigabit Ethernet link carries all encrypted traffic. A traffic generator supplies the traffic across 8 10 gigabit Ethernet ports. A second identical Turbo IPsec gateway terminates the IPsec tunnel. All measurements are performed on the first gateway. For all tests, gateway software configuration is identical. The data plane has 8 dedicated CPU cores. 2 virtual routers are configured. IP and IP encapsulation and filtering are enabled. The next test demonstrates 6-win Turbo IPsec zero loss throughput for a single tunnel. Virtual routers, IP and IP encapsulation, and filtering are enabled. The traffic generator is started. The traffic generator gauges indicate an aggregate throughput of 16 gigabits per second with a packet size of 1,420 bytes. That's 16 gigabits of traffic over a single IPsec tunnel. This next test demonstrates 6-win Turbo IPsec zero loss throughput across a multi-tunnel scenario. The 6-win Turbo IPsec configuration remains unchanged. The traffic generator is started. This test generates traffic in both directions across all 8 test generator ports. The gauges monitor the 100 GigE port and indicate an aggregate rate of 56 gigabits per second with a packet size of 1,420 bytes. With virtual routers, IP and IP encapsulation, and filters enabled, 6-win Turbo IPsec achieves 56 gigabits per second of IPsec processing capacity. That's 7 gigabits per second of IPsec processing capacity per core. The data plane CPU utilization graph shows actual core utilization is at 100% across all 8 cores. With the performance demos done, the security and resiliency demo is next. Connecting to an untrusted network always comes with risk. 6-win Turbo IPsec provides virtual routers, filters, and high availability features such as VRRP, link aggregation, and IPsec HA to mitigate the risk. Virtual routers operate independently of each other as if they were standalone. Virtual routing provides a means to clearly isolate public and private networks. In this example, all incoming packets are subject to 2 independently configured firewalls. Filters are the first line of defense for a network, and each virtual router can have its own unique set of filters. The virtual router outside is configured with a filter that accepts encrypted packets and rejects or drops all packets in the clear. Another part of security and resiliency is high availability. Port level high availability comprises link aggregation and guards against a link failure. This failover is immediate and is transparent to IPsec. To provide system level redundancy using VRRP and IPsec HA, 6-win Turbo IPsec is deployed on multiple COTS servers in active standby configurations to ensure fast failover. In normal operation, the tunnel terminates at the active security gateway. When the active gateway fails, the tunnel immediately fails over to the standby security gateway. This failover is transparent to IPsec. Next, the system level high availability demo. The bottom gauges show the traffic generator transmit and receive rate. The top gauges show traffic flowing through the active security gateway. We shut down the active security gateway. The gauges confirm the security gateway is down. The traffic generator gauges show no appreciable interruption in received traffic. We check the standby security gateway and find it is now the active security gateway, confirming proper local redundancy operation. We move on to management and monitoring. Many options are available for site-to-site management and monitoring. In the demos, we took advantage of third-party tools to monitor network throughput, IPsec statistics, CPU utilization, and also data plane statistics. The last requirement is virtualization readiness. Virtualization readiness means the same 6-win Turbo IPsec software is deployed on bare metal, on KVM, Hyper-V, and ESXi virtual environments. In closing, we've shown that 6-win Turbo IPsec is a cost-effective alternative to hardware IPsec VPN appliances that is high performance, provides security and resiliency features, provides management and monitoring functions, and is virtualization ready. Contact us today to learn more about 6-win Turbo IPsec for your specific requirements.